Thank you, Michael. So, going to be talking about machine learning. Just to get a sense of the room, with a show of hands, if you know about AI, machine learning, okay, great, awesome. And if you've used machine learning in any technical capacity, okay, awesome. There we go. That's it. Alexa.
Google Home.
Nice plugging. Nice. Yeah.
Well, I'm going to be talking about a little bit of that. So we're going to be talking about machine learning. For those of you who don't have an introduction, I'll give a very quick introduction. Really, the talk is about, as a business owner, what are the things to watch out, and what are some of the learnings that could be valuable, right? And so I really put a lot of thought about, hey, if I was developing a business or if I had an existing business, how would I go about approaching a problem in this day and age where machine learning is becoming super important. And it's become so important that essentially I think going forward it's going to be essential. It's going to be essential for every business owner, and I think it's going to be essential for even if you're a technical person, if you're an architect, if you're a developer, I think it's going to be essential to have these skills going in the future. I deal with customers of all sizes in my capacities and in my day job with AWS. We're the biggest public cloud provider, if you don't know. I'm a solutions architect. What that means is I work with customers of all sizes, small startups to really large organizations, and advise them how to go about using our services. Some of the largest companies that you'll know are completely running on the public cloud. So we have a lot of machine learning services as well, which I'll be briefly talking about, but mostly staying on topic about what's relevant to the business owner. And some of the things get a little bit technical as well. So I want to set the stage a little bit. It's 2013, and the Associated Press Twitter feed gets hacked. And the tweet that goes out says something about 2 explosions in the White House. And immediately what happens is there's a 140-point drop in the stock market, in the Dow. And it recovers within 6 minutes. So a lot of people end up making a lot of money, and a lot of people end up losing money. And so what does this show us? This is essentially a technology called sentiment analysis. And this is a result of sentiment analysis being used by multiple hedge funds, traders on Wall Street, and sort of using it in the same way, where they're taking this text in a Twitter feed and they're analyzing in real time what is the sentiment. And there's no human involvement. The algorithm goes in and says, something's really bad happened, and obviously it happened at the White House, and so let's short our positions or let's get out of the market right away without any human intervention. So think about that. We've had other flash crashes as well, by the way. So that's 2013. 2014, Siri, how do I get here? Alexa, call me an Uber.
Okay, you're an Uber.
Right? And so all of a sudden, overnight, we're talking to our computers. It's, we've been dealing with interfaces for a couple of decades, maybe more. But all of a sudden now we are talking. And so this, you hear about the graphical user interface. Say hello to the conversational interface. And I think this is going to be super important going forward. It already is. A lot of my customers are saying, how do I do something like this? Where instead of touching a screen or pointing a mouse over a button or something, where my customer goes in and says, I want to talk to your service. right? 2017, this is pretty recent, some of you might already know this. Image recognition. A team at Stanford comes up with an algorithm that looks as an X-ray, at a chest X-ray, and is able to diagnose better than the world-class radiologists that are there. This is pretty amazing stuff, right? What made it possible? Flash crash, like I mentioned. Trading bots using sentiment analysis, using a technique called deep learning. Amazon Alexa uses a couple of technologies. Automatic speech recognition, ASR, which converts spoken words into text. And then another one called natural language understanding, NLU, that actually deciphers meaning out of those words. What am I trying to say? What is my intent? Also based on deep learning. Image recognition. That's what the Stanford team is doing, looking at an X-ray. Also using a type of deep learning. And what is this? And these are all examples of machine learning. So this is great. A lot of people say machine learning and AI, they're closely related, but they're not the same thing. So let's start off with looking at that. What is AI? What is machine learning? What is deep learning? AI is the broader subfield within computer science, where computer scientists are trying to mimic human intelligence. Within that, we have the subfield of machine learning. And within machine learning, what we do is essentially we give an algorithm historical data so it can learn patterns and behavior, and patterns essentially, it can identify patterns from that historical data. So that's machine learning. And then there's a further subtype of deep learning that I mentioned before that enabled most of these things that I mentioned previously is deep learning, where we use this construct called neural networks. And we have a number of layers of neurons, so to say. These constructs actually mimic, in a very, very crude way, not coming even close to the human brain. And this is where there's been a lot of advancement in the recent years. So we will talk about that. And so quickly I want to touch upon traditional programming. So let's say that you were trying to predict something, maybe predict the what the temperature is going to be tomorrow, right? And so traditional programming, you will have an actual human programmer go in and maybe do some kind of coding where they're statically putting in some rules and say, okay, if the pressure was such today, and whatever weather conditions are today, and the moisture is such and such, I predict that it's going to be this. How it's different in machine learning is that you don't really need someone to write those static algorithms. What you need is someone that's proficient in using a machine learning training algorithm, and that training algorithm actually goes into the historical data and finds patterns, and then magically comes out with a thing called a model. And what this model is essentially all the rules that this human has identified. It's automatically identified here. But the biggest difference is that as humans, we can maybe look at 10 different attributes and say, I want to make rules about these 10 different attributes. This algorithm is able to look at thousands of these attributes and decipher meaning out of it. And so at the end of this, you get a model, and then you can feed in data and say, okay, tell me what the temperature is going to be tomorrow. And so that's at a very high level what machine learning is and how it's sort of different from traditional programming. there's a long heritage. I'm not gonna spend too much time on it. We've been applying machine learning at Amazon for a long time. People mostly know about Pioneer, automated drones, and the Amazon Go store and Alexa, but we've been recommending books since the 90s. So there's a lot of expertise within Amazon, and we offer a bunch of different services. I'll be happy to talk to you about all these services. I focus on them at my day job. You're welcome to come and talk to me afterwards. I'm not going to go too much into it, but essentially, whatever your expertise is, if you are a computer scientist and you're deep into this deep learning and you're a data scientist, you can use our infrastructure, you can use any of the frameworks. If you are a newbie and you're maybe starting out a business and you're looking at stuff like how do I analyze text to see what customers are saying about my product or service, what kind of images my customers are uploading, I want to identify stuff in those images. We have higher level APIs where you just send us the image, just send us the text, and we'll give you information about that through the use of a simple HTTP API, REST API. So we have a bunch of these services. We can talk about that later, but you might ask why now? Machine learning has been around for a while. Neural networks was something that was sort of discovered and wrote about in actually 1950s. So they've been around. What's changed is essentially three things. Number one, algorithms. So we've applied new algorithms, especially within the realm of deep learning. There's been a lot of advancement in, I would say, the last maybe 10, 12 years. So there have been advancements in algorithms. The other one is very fast hardware. A lot of this technology, most of this technology is powered by doing a lot of calculations. So if you ever taken like linear algebra or something in college, it's based on that. And so you do a lot of that, and as your data size increases, so does the calculation, the amount of calculation that you have to do. And so you really need very fast hardware. And a lot of things came together. One interesting bit is, and especially for gamers out there, that drove the need for computer graphics. And the computer graphics actually use the same kind of calculations. And to enable those gamers, chip manufacturers came up with this thing called the GPU, Graphical Processing Unit. And now the same math is being used in machine learning, and we're using the same specialized chip to do machine learning. And so there's been a lot of advancement here as well. But the key here is I think, in my opinion, is data. And I want to focus on data because I think, algorithms are out there. Most of the algorithms right now, pretty cutting edge algorithms, are open source. You can use them. You can hire someone. Yes, large companies will take the world-class talent, but there are a lot of people that can use the algorithms. The hardware is available to anyone. You can go on AWS, get hardware by the hour, even by the minute. The key enabler here for businesses is data, and how much data you have, right? And so data, what's changed here is previously we didn't have a lot of data. And now with the advent of internet and cheap storage, companies have been collecting this data for a while now. And this is pretty apparent when you look at stuff like Cambridge Analytica and what happened with Facebook and stuff, right? They had so much data, so many attributes about us, that they were able to predict who was on that borderline and where we can target our ads and fake news and get them over the edge to the other side. So just think about that, how powerful that is. One interesting bit about data, first of all, if you don't have data, you don't have learning. And so in machine learning, one prerequisite is that you have to have data. And what I mean by that, so let's say I'm trying to predict the price of a house, right? I'm trying to sell my house, and I want to see, I want to understand like what would be the price where I would list it, right? And so I'm trying to predict that. And so if you're working with a realtor, the realtor would come and probably give you comps around the area, similar size houses in your neighborhood. And so you're looking at number of bedrooms, square footage, number of bathrooms, right? And for your zip code, and you can predict that, right? You can predict that pretty easily. And so you have to have, and you can use the same data to power your machine learning algorithm as well. And so you give that all that information that, hey, this is these many bedrooms, this square footage sold for this site. So I have historical data, and my algorithms is able to learn, right? And so we have to have data. Now, the amount of data is also very is super important as well. So if you have a few hundred examples, right, or maybe a few thousand examples, then it's probably better to just stick with the traditional machine learning, because if you look at this, as the number of examples increase, as the amount of data and number of examples increase, this is very quickly, this is the performance or the accuracy of the model. It goes up really high, very quickly. So you get, pretty good results for not a whole lot of data. But if you have a lot of it, then you want to be leveraging some of these advanced techniques. And that's where the magic happens is, this thing, the traditional statistical models that have been around for decades, plateau at a certain accuracy level, let's say about 85% accuracy. Versus if you have a lot of data and you're using some of the latest techniques, these algorithms keep learning and keep increasing their accuracy. And sometimes we wonder, oh my God, how does Facebook know this, or how does Google know this about me, right? So that leads us to our key insight number one is data is gold. If you're a business owner, if you have access to key data, you should definitely store it and try to get as much insight especially about your customers. A lot of business owners care about customers, what they're saying about their product or service, so that's super important. Having lots of data is super important. And then wide data as well. What do I mean by wide data? So having a lot of examples, so pretty much knowing all your customers is super important. And then knowing as much about every single customer is super important as well. And so that goes back to the example that I gave about Cambridge Analytica. They had so many number of attributes about that one person. What kind of articles was that person clicking? What kind of things that they were researching on Facebook? That they were able to make this insight of who they could turn, right? Another thing that we hear people say is we want to automate. We want to use, okay, this is great, machine learning is awesome. We want to automate everything. And so like with everything else in life, there is a balance here, right? And so some of you might be wondering, where is your Tesla 3 right now that you ordered last year? And so excessive automation is probably not a good thing. And so when you're starting out, just know that it's hard to see. I should have used different colors, but you have this graph for humans in terms of time and productivity, and then you have this other graph that's a little bit harder to see here for machines here, right? And the key point here is if you give a human something to learn, we learn very, very quickly. Machines are not there. As fast as they are, they're not there, right? It takes them time. So this time is really about all the data that you're gathering, right? And you give them thousands, millions of examples, and that's when they're sort of getting close to the human level. If you give a human a couple of examples, they'll start right away, right? You show them how to do something one or two or maybe three times, and they can replicate that themselves, right? And so this is super important, and that leads us to our key insight number two, which is automation versus augmentation. Not every problem is well suited for ML, just understand that. You have to have a lot of good quality data. And what I mean by a good quality is you have to have stuff that's learnable within that, and I think I'm gonna touch upon that a little bit as well. The other thing is there are going to be problem areas where you are defining solutions where it definitely makes sense to have a hybrid ML AI approach, right? A very sort of crude example is of Redfin, right? Redfin will use AI and ML to give you a price estimate on your house. But then they have the human realtors, they have you need that human touch in certain instances, right? So some of you might remember this. This is where IBM Watson was playing Jeopardy, right? And as a result of this, and Siri and Alexa, we get a lot of this. We'll have a business owner come to us, I have a lot of data. Let's connect your magic algorithms to my data and then see what we can learn from it. Guess what? That's not what reality is right now. So if any of you are thinking about a general purpose AI, Singularity is not here. So you have to be very specific about the problem area that you're going to solve. And I was just talking to Michael about his thing, where you're maybe at a certain point you wanna go look at what is this image that my customer is giving me? What's in that? That's a specific area. If my customer is trying to chat with my customer service, what are they trying to do? Can I automate that? That's a specific area, right? What are people saying about my product service? Is this person, I know that this person is female, between 30 and 40. She probably lives in this area or accessing my service from this area. Is she likely to make a purchase on my site through my app, right? And those are the type of questions that you want to answer. And those are the type of problems that you go after individually. There's no general purpose AI. You can't just connect something to your data and find out magically solve all your problems. Does not exist. And then we go into the racist chatbot. So this is a chatbot. So chatbots is sort of an application of machine learning where you're looking at natural language and you're trying to decipher what a person is saying, right? And so Microsoft a while back released this chatbot, and the idea was that the chatbot will learn based on what the user is saying to it. And guess what? Some people perhaps maliciously were malicious with it, and it went pretty nasty and very quickly, right? So they had to take it down. What's the lesson learned here? Garbage in, garbage out. The data that you have should have learnable aspects to it. You can't just take random data and expect that you'll magically learn something out of it. A quick example would be, when you talk about predicting in machine learning, a lot of people go and try and predict stock prices based on historical stock prices. And that's an area of expertise. A lot of hedge funds do that, but they don't just look at just the previous historical stock prices. If you were to try and predict the stock price of Apple just based on the history, it's going to be a futile exercise. There's no learning to be had from that, because that stock price is dependent on other stuff. That stock price is dependent on the public perception of Apple, of their last earnings, of what the news media and the public is saying about their brand, right? And so you have to have data that has learnable patterns. Quality matters. Then we get into this stuff. I'm just starting out. I don't have any resources. I don't have the money to have gigabytes or petabytes of data. So this is not applicable to me. deep learning doesn't apply to me. I don't have data. I'm not Google, Amazon, Facebook. So, maybe I should not look at this. Wrong. You can do a lot with it. You can, first of all, as a startup, see if the problem is complex enough that it requires deep learning. For most predictive analytics problems, you're probably going to be better served with using just a plain old statistical model, not using deep learning. If you do require deep learning, then look at a higher level API that you can buy from a cloud service like ours. The other one I would say, and then that's really the point for those interested in machine learning, is this concept of fine-tuning, right? Let's say I have an app that's where I'm trying to grab nutritional information just by looking at the food, right? I can use existing models that let me recognize pizza from a hamburger, from a cheeseburger, and I can retune that model to get more insights and get it to be more specific to my business use case. So you can definitely use existing stuff. There's word embeddings out there for text. There is image recognition models that you can retune to your specific needs. So definitely possible. So I'm gonna breeze through the rest. This is what a machine learning cycle looks like. You have some data that you do some exploration on, you do some training, you get a model out, you deploy it for inference, then you learn from it, and then you try and improve it, right? And so one of the key areas that people miss is they focus on training, but they don't do what's called exploration and feature engineering. Feature engineering is key. Quick example, let's say you're trying to predict seasonal sales, and within your historical data, you have something like this, a timestamp. That's how things are stored within computer storage, right? It's seasonal sales, so if you give this timestamp to a deep learning model, you're probably not going to get a lot out of it. And so this is where experimentation, this is where you need someone who really understands your business and is able to say, okay, is your business seasonal? So it's probably better that before I start learning on it, I infer these two things out of it. That, hey, this was evening, the season was fall, and this is what my sale looks like. So this is a sale that happened in the evening in the fall time. And now you could, you'll have a model that would be able to get more patterns out of this data. Another one, should I build my own custom model or should I use an API? Very good question. It really depends. From our perspective, I think a lot of different customers and different businesses would end up using a general purpose API from a major provider like Google or Amazon or anybody else, right? If it's not your area of expertise, then don't do it. Use an API. If you're in healthcare company, maybe an insurance company, maybe you want to use a vertical specific API, or somebody who's super deep into your vertical, right? Use an API with them. And then this is where BYOM, bring your own model, that's where you write your own custom model. Very expensive, but highly valuable. So if you're trying to differentiate, then definitely worth it. So this key insight, invest in custom models, competitive differentiation. If you have a lot of data that only you have, then use that as competitive differentiation. You should be training your own models. Otherwise, look at cloud APIs. And very quickly, I want to really emphasize this, that this is, which programming language and deep learning framework should I learn? There are a bunch of them out there. The key insight there is, as you go up the stack, it becomes easier. This is more for the experts. So if you're starting out learning yourself, then I would highly recommend Keras, Gluon, PyTorch, scikit-learn. If you want to do this yourself. There are a bunch of different frameworks out there. Look at the community support, the language of programming language, whether it supports distributed execution. But again, this is a little bit more for the experts here. and portability, right? One thing to note is Python is by default the language of choice here. So another one, we don't have developers. I'm a business owner. I can't hire PhDs to build models. Consider retraining your devs. Like I mentioned before, I think developers are probably going to need this going forward. They should have some machine learning knowledge. There are excellent resources out there, so you can definitely retrain the developers. If you're a developer yourself, there are awesome free resources, which is my last point. Learn and be curious. It's an Amazon principle as well. You keep learning, no matter what stage. These are three of the great resources that I found. Fast.ai, free. Andrew Ng's course is amazing. This is probably the best course that anybody could take. It's a Stanford course. You can go to Coursera.com and take it for free. If you want a little certificate at the end, you'll pay like $80 or something. But this is for the value that you're getting out of it. You're taking a course from a teacher at Stanford. This is amazing, right? And then this is an MXNet gluon.mxnet.io. Great tutorial on deep learning as well. And there are a bunch of others. There is University of Washington. There's so much stuff on Coursera that you can find. So a lot of free stuff that's available out there, so educate yourself. And that brings me to my close. Thank you so much.
Excellent detailed presentation. Really interesting to see sort of the evolution and also use case scenarios of artificial intelligence and machine learning. And also just the distinction between basic machine learning and deep learning, and helping us understand like what those differences are, APIs that we can plug into immediately, and also really just investing in more infrastructure in the event that our system, whatever it is that we're creating, whether it be a physical product or just a software product, the differences in what we should actually do, and sort of transitions from beginning stages to end stages. So that's really awesome. We really appreciate that. How many people in the audience are working on something that's really technical that needs machine learning and or artificial intelligence? Raise your hand real high. That's a decent amount. That's like maybe 20% of the people here. That's awesome. So really great practical information. We appreciate that. We're opening up to Q&A now, so if you have a question, raise your hand. John will walk around with the mic. Ahmad, will you be hanging out with us a little bit afterwards?
Yeah, absolutely.
Okay.
I'll be here.
So storytelling offline right now, no comments. Just please ask a question. We'll get it answered for you. Thanks.
Still need the
Oh,
mic.
Is this on?
Hello?
Yep.
Hi. In terms of what you said about inferring from data, I'm wondering if you're starting a new project, is there value to when you save, say, a timestamp, save file right away, to skip that step? And also, is there a benefit of NoSQL versus relational databases?
Yeah. So can you repeat the first part of your question? I think I missed.
Oh, sure. If you're starting something new and you're just writing a model to not the kind of model, just a data model to save, say, a timestamp, is there value if you plan to do machine learning to do inferring right then and there, like store also fall right in that same row right away instead of waiting?
I would say if you're not doing machine learning, then just save it the way you would save it, because once you start doing that machine learning, you can do feature extraction at that time. It's really part of that machine learning cycle. Second part of your question would be SQL versus NoSQL. It's really dependent on your use case. What we see is people traditionally have been using databases like Oracle and MySQL and stuff. That's where you have a lot of transactional support. If you're building something of a financial system, you'd probably want to use a relational database system. Versus a lot of the machine learning applications, the data is very unstructured. It's like click streams. Where are my users clicking and going into my website and whatnot? That's a lot of unstructured data. And so that's where you want to look at something like a data warehouse, look at storage systems like S3, where you're just using those systems to store that data in files rather than very expensive relational database systems. So very good question. I think one of the major things that we're seeing out there is a lot of these large enterprises that have a lot of data, and they have hundreds and hundreds of different RDBMSs. so basically relational databases. And what they're doing is they're transforming the data and putting it into what they call the data lake. And so they will have all their server logs, all their user interactions, all their purchase history going into a file-based system where it's very, very cheap to store over time. And the Amazon service for that is Amazon S3, which is highly scalable storage, and you can just put files on it.
Thanks.
Okay, my question, thank you. First off, you did a great job synthesizing a very complicated issue. So I wanted to expand a little bit more on the data integrity side of things. What do you guys do, or what are best practices for stripping out bias from data? Because if that data is biased, it's learning from it, you get where I'm going. I'd like to know if you can expand on that.
Yeah, so unfortunately, from a machine learning perspective, if your data is biased, then your prediction is going to be biased as well, right? And so just like the racist chatbot, if you're putting in garbage is going to come out. What I see customers doing is a lot of times, now with the recent GDPR requirements as well, this goes into privacy as well a little bit, right? Where you have a lot of PII, like personally identifiable information, like people's security, date of birth, credit card numbers, social security numbers are in the data, and sometimes. And so you can use some of the machine learning API services to actually, they can go and discover all that private data, and you can extract that and get rid of that data. And so connecting that to your original question about bias, if you're looking at, like, for example, something like a product review that's very, very negative, right? And somebody had a really bad experience at your restaurant, right? And you have 100 5-star reviews, and then you get that one 1-star review, right? And that's heavily biased because, I don't know, something happened, the server didn't serve them right, even though the food is awesome at your restaurant, right? I would say that that's part of your feature extraction, data exploration, where you really go in and you try and see and you do sentiment analysis on those reviews, and take them out. And so then you're doing, like, you're doing sort of a P99 where, like, you're just going and looking at a subset of examples, and you rule out, some of the anomalies out. And that's should be part of that step where you're exploring your data and you're trying to do feature engineering.
Hi, how you doing?
Good.
I look at the 3 machine learning models that you guys offer, and it looks like you guys offer the convolutional neural network. Are you guys looking to add reinforcement learning anytime soon? And if so, is that a synergy solution that combine mechanical Turk with reinforcement learning, so we can use human to train AI models?
Yeah, absolutely. So here's the thing. So we have the higher level APIs that do text analysis, that do speech recognition, machine translation from one language to the other, that do transcribing, that also do, there's a service called Comprehend that gives you entities, organization, people mentioned in text and stuff like that. So those are higher level APIs, right? You're mentioning convolutional neural networks. So we offer support for all the major deep learning frameworks. So you can build convolutional, you can build recurrent, you can build just deeply connected deep neural networks, any kind of networks, right? So there's no restriction in terms of what you can build. If you're using some of those deep learning frameworks on our infrastructure, it's really up to you. You can go build any kind of system. You can build a reinforcement learning system. And just for those of you who don't know what reinforcement learning is, it's a type of, there's deep learning, then there's reinforcement learning. Reinforcement learning is where you're giving the algorithm a goal, and you're giving the algorithm a set of constraints. And so this is the type of learning that powered the algorithm that beat the world champion in Go, right? And so the constraints were the rules of the game, right? And the goal was to maximize the score. And so there are algorithms out there that you don't need any kind of sort of training data in that instance, right? So if you can launch, there was a famous example of this algorithm trying to learn how to play Pong, the classic computer game. and it learned the rules themselves, and there were few constraints that were put on, and then the end goal was to maximize the score, right? And so you can absolutely build reinforcement learning systems on our end. We support pretty much all the major frameworks that are out there, and it's really up to you. In that case, you're building the system, right? So
Over here.
hope that answered your question.
Ahmad over here.
This is more high-level question, not as specific. So in terms of the manipulation of the data, already we see Cambridge Analytica being able to manipulate people through it. Clearly, legislators aren't going to be able to regulate it because they don't understand it well enough. So what is to prevent another Cambridge Analytica happening every day on some level? Are there any ethics involved? Is Amazon and others, do you see them being concerned about how to apply that?
Yeah.
You know,
Absolutely, very, very valid question, very important question. Whenever you have something powerful as this come out, internet came out, there are valid users for it, and then people like bad hackers, not the developer hackers, malicious users, trying to do bad stuff. And so whenever something powerful like this comes along, there's going to be malicious actors like Cambridge Analytica. Look at what they did, right? There's a huge concern about ethics. There's a whole ethics organization that was formed by, I forget the name, but it's a partnership between Google, Elon Musk, Amazon is also a player in that, and they've made an organization that's dedicated to ethics in this field. And what they're purporting is they're a proponent of actually some kind of regulation in this space as well. And you'll see more and more of these regulations, just like GDPR in European countries. They're requiring companies to let you know as a consumer what they're capturing.
Like when you're advising, do you ever shut it down, or
When that's really up to a government organization, right? I mean, we as a company don't have the authorization to go and shut some business down, but like what we do is, and this is true for stuff outside of area of machine learning, is if someone is using our services in a way that's harming other services in a malicious way, we'll shut them down.
Okay.
Absolutely. So we do that, and we do that across all of our services. And if you go and read our terms of service, if you're in violation of that terms of service agreement, and we find out, then we are going to shut you down. Absolutely.
Up front. Question.
Yep.
Okay, I just want to change it to healthcare. I'm an oncologist, so I recently read a book that's called Master Algorithm.
Yes.
So
Edward Domingos. Yeah, it's a great,
right.
great book.
So, but I think he's too simple. He's not a medical oncologist. Let's put it this way. He make it too simple. So what I want to know is this: we struggle right now. I mean, his point was we can build a computer to cure cancer, right? So I kind of agree with that. The questions I have is, so the tumor itself, we can collect about at least minimum of 100,000 biomarkers on this tumor. As of today, we use about 2-3 to make a decision for treatment. So if we can use all 100,000 of that, then we will be able to be more of the precision medicine that we're striving for. So do you think that the AI or the machine learning today, is it there yet?
It's absolutely there.
It is?
It is. It's
Okay.
absolutely there.
I need your
I bet
business
you
card.
there. I mean, I'm not an expert in obviously in healthcare application of this, but you saw the example of that Stanford algorithm diagnosing pneumonia, just looking at chest X-rays, and it does it
That's
better.
imaging, though. That's different.
That's imaging, right?
Right. We
But
talk
even
about
in
molecular
genetics,
biology.
yeah, absolutely. So even in genetics, this is being applied, and you're talking about 100,000 markers. This is exactly the type of problem where this comes in very, very handy, where you have not just hundreds or tens or hundreds of attributes, you have 100,000 different attributes. And you're looking across them and trying to find patterns, which is not humanly possible.
Right.
Right? So you're looking at maybe 3, 4, maybe 5 attributes. These algorithms are absolutely capable of looking at thousands of attributes. And so, yes, machine learning is there. I think it's it's the marriage of the two disciplines, right? And somebody coming along that has enough knowledge, or some teams getting together that have enough knowledge about your area of expertise and machine learning, and then developing a solution.
Because you said data is gold, and we have so much data, but
Mm-hmm.
we just cannot possibly interpret them at the same time.
So I mean, we have the compute power, so it's a matter of if you have the data, then it's a matter of getting enough funds for you to buy that computing power to churn through that data. It might take a while, but it's absolutely possible.
We're willing to put in 3 to 5 years.
Yeah, I mean, so my question would be, do you have more data than Facebook? If Facebook is able to do facial recognition for almost every person on the planet, maybe you have the same scale, but all you need is really access to computing power. And if you have viable ideas, people will fund that, and you can absolutely go and train a model. And it's absolutely
It's
there.
here, so it's here.
Yep.
Awesome. That's a wrap up for the Q&A. Thank you so much for your questions.